Oh, man, we'll need an extra class maybe, so.
All right, as for today, we are getting into one of my favorite sections, which is factoring. And the reason this is such a fantastic section is that there are several moves to the polynomial dance in this.
Hey, thanks, buddy.
So factoring, all right, is all about breaking things into their primes. All right, does anyone remember what the definition of a prime is? Your prime number,
Can't be divided.
not odd,
Can't be divided.
close.
Can't be, only is divided by itself or something like that, like one divided. by-
One and itself, all right? Numbers that can only be divided by one and itself, all right? Which means, as a note, one is not a prime. The very first prime is what number? 2.
Oh, two, yeah. That's right.
Only way to make 2 is 1 times 2. All right, so it is not, primes are not just odd, all right, which, I mean, after 2, they all are, but like, that's the biggest thing, all right? So, 2, 2, 3, 5, 7, 11, 13, right, 17, we could keep going, all right? So that's what primes are. So something known as prime factorization is how you break primes down. Basically, we just start identifying, and with a polynomial, all right, break it into its number. All right, and then the variable, and then you just keep breaking these down into prime numbers, 3 and 5, and x cubed breaks into x times x times x. That means the prime factorization of 15x cubed is 3 times 5 times x times x times x. All right, you can have multiple, all right, so there could be lots of 3s, 5s, 7s, all right, but as long as you get it down to each of those values. And when you multiply it completely back together, you should get whatever you started with. So the whole idea of factoring is that factoring is breaking things apart, and up till now, we have been putting things together. Rainbow, box, all right, that is combining like terms, right? Adding in something, that's combining things. So factoring is the opposite. It's breaking things into its simplest parts. The very first one is greatest common factor. Okay, this is the opposite of rainbowing. So rainbow is putting things in, all right? Greatest common factor is pulling things out. Okay, so same thing with this one. Rainbow in, pull it out. All right, this one, same thing, hip hop and slide, okay? All right, so all of this is reverse rainbowing. I want to identify basically, I'm still gonna have something and it's still gonna have 3 pieces remaining. But this term right here, what does all of this have in common? 7, well done, all right? The greatest common factor, okay? So start with the largest number it all has in common. When I pull, and then do it one piece at a time. When I pull 7 out of 7x cubed squared, what's left? X squared. Don't forget, all right, your operators in between, plus, all right? When I pull 7 out of 28x, what's left? 4x. And lastly, when I pull 7 out of 14, what's left? 2. Notice, all right, if I am to rainbow that 7 in, I end up back right here. The big part, okay, and now be aware, we're not solving this. This is just factor, okay? So this is, it's not simplify. Simplify would end up back here, all right? We're pulling things out. So again, knowing when to stop is important. That's all we can do there.
So it's complicating it, got it.
Not complicated. It's actually trying to make things simpler. Lower numbers. Is 7 easier to deal with than 28? Right? 4, 2. Notice everything, the idea is everything gets smaller. All right.
You finally said something I understood.
Well, no.
No, you said, this, simplify it, all right.
Just the opposite of simplifying it, make it more complicated.
It's the opposite of simplify, but it ends up in a simpler form. Okay? All right, same thing. Let's do it with the top. What's the largest number I can pull out of all those pieces? 3. So notice, right, you kind of are looking for the smallest number and what's the biggest thing you can pull out of the smallest. What's the largest variable I can pull out?
Squared.
Well done. So when I pull 3x squared out of 15x to the 5th, what's left?
5x cubed.
5x cubed. Remember, it's adding the powers, right? X squared times x cubed results in x to the 5th. All right, these are those rules of exponents that we were doing in chapter 5. Minus, notice the operator doesn't change, okay? The addition or subtraction remains the same. What's left in the second term? In the third term? And the last term? Oh, well done. That's the big part. A lot of people are like, well, I pulled 3x squared out, nothing's left. No, remember, it's reverse rainbowing, so I have to be able to multiply in. So if you pull the entire piece out, there is still a 1 remaining, all right? Because I multiply this back in, and I have to end up with this. So the 1 is the placeholder there, and that's a key item. All right, so greatest common factor is a big one. Factor by grouping, okay, so we're gonna look at how to pull apart 2 terms, 3 terms, and 4 terms. 4 terms, all right, the most common approach is 2 by 2 factor by grouping, which basically means you look at 2 terms at a time and pull out the greatest common factor within each of those. On this first piece, notice that within the parentheses, I have x plus 1 in both these pieces. So if you pull the x plus 1 all the way out, the other way to view this is let y equal x plus 1. And notice what this will become, x squared y plus 2y. So if I was to do greatest common factor there, what would I pull out?
Y times x squared plus 2.
Just the y. Yes, you already did it all the way down, yes. I would pull out the y. which would then result in x squared, y times x squared plus 2. The idea is this whole piece is something you can pull entirely out. Now I replace that y back with x squared plus 1. And it results in x plus 1 times x squared plus 2. This is the goal of factor by grouping. We pull out some piece, whatever we call that, all right, and it comes all the way out. I represented it that way because a lot of times people are like, well, I pull an x plus 1 out, but I still have one over here. Nope, you're factoring it entirely out. In the more generic terms, now factor by grouping only works with 4 terms, all right? So notice, all right, I have 4 terms here, 1, 2, 3, 4. So counting our terms is going to be a big deal. Basically, I underlined it, don't put parentheses in. Why do I not want to put parentheses? Yes, because it becomes multiplication. Way too often people want to, I'm just underlining it to separate 2 terms and 2 terms. So then I just do factor by grouping on the first 2 terms. What is the greatest common factor of those first 2 terms?
X squared.
X squared, that's it. So I'm ignoring the second half and I'm just doing our greatest common factor on 2 terms. So I say x squared. What is then remaining? 7x plus 2. Of the second 2 terms, what is the greatest common factor?
2.
Almost.
-2.
Ah,
-2, yeah.
crucial there. All right, negative and a negative, which means not just 2, but -2. So I can pull a negative out of there as well. What's remaining there, Fred? If I pulled a -2 out of -14x, what remains?
X.
X. Anything else? Thank you, Fred.
Well, as I say, you still have the -4.
We're just the first term. So what's left? All right. -2 times what makes -14?
7, -7.
Positive 7.
Yeah.
All right. Then the second term, right? -2 times what makes -4?
+2.
+2. And basically, that's all this is, all right? Reverse rainbow. Because I have to multiply, and every time I'm just filling in this blank, 1 piece at a time. Now, here's how I know factor by grouping worked. 7x plus 2, 7x plus 2. They have to match. And it's super common if we had missed the negative or whatever, you'd end up with a negative. If the signs are off or anything, all right, that means you didn't pull out the greatest common factor. As soon as you identify they match, pull that 7x plus 2 all the way out. What's left?
X squared -2.
Yeah, basically you just cover these up and you say, oh, it's x squared minus 2. So you pull that all the way out. And here's the other thing. In order to verify that this results in this, what would I do? No, not rainbow. Box. All right. So you box this together and you will end up with this. All right. All we are doing, right? We are reverse rainbowing. We are reverse boxing. That's what factoring is. All those techniques we learn to combine terms, we break terms apart. All right, let's do a couple more of these, make sure we really got it. 2 terms and 2 terms. Of the first 2 terms, Brittany, what is the greatest common factor?
Greatest.
2.
Anything else? I believe 2 is the greatest common factor between 8 and 6, but what about x to the 4th and x?
X to the 4th. The X to the 3rd.
No, not x to the 3rd. Greatest common factor, it can't be bigger than the smallest piece, right? So 2 is less than 8 and 6. So can it be x to the 3rd? Because if I only have an x, this is x to the 1st power, right?
So you have X to the
X to the what?
5th. So you'd add the exponents?
Just x to the 1st power. The greatest thing I can pull out of x is x, right? 5, right? The greatest thing I can pull out of a 5 is a 5. I can't pull 25 out of 5 without making it a fraction. All right, let's see if we can go the other way. Fill it in. All right, Brittany, you're still on deck, or at that. X, 2x times what makes 8x to the 4th?
You have 4.
4.
4x. Right here. And then plus 3x.
Okay. X times x makes,
X times X makes X squared.
right, but we need an x to the 4th. So x times what makes x to the 4th?
X.
X times x squared becomes,
X to the 4.
anyone help her out?
That's X to the 3rd.
There's the x to the 3rd.
Yeah.
What?
So they're going like this.
All right, and then 2x times 3 makes 6x, all right? So I don't need an x there because if I added another x, that would be too much. All right. Josiah, what's the greatest common factor of the second 2 terms?
7.
Very close. Notice the signs, though. Is it 7? -7. All right, can I pull an x out of those as well?
No,
Why not?
I'm not really sure.
Because there is no x in the last term, right? Can't pull something out that isn't there. Brian, what is inside the parentheses?
-4x,
Hold on, negative?
no, positive.
Positive 4x.
Plus 4, I'm pretty sure. No, 3.
Are we sure that's correct? -7 times 4 is -28. And then that would become -28x. Is that what we have above?
No.
Nope. What do I need?
Cube.
Cubed. What's a good way to verify that the second term lines up?
Oh, it's
Yeah, look at the first term, right? So all we have to do is check the term. Now, don't just auto put it in there, make sure the math works, okay? But every time, I just need to look at this one because that at least gives me an indicator of what the second term will be. I pull it all the way out once again, 4x cubed plus 3, -2x minus 7. And again, be aware that you can box that back together and you always should to verify. I always just like to make sure that I'm doing it correctly the first time, but, right? Till you guys are pro, till you do all the practice problems, all the home fun and all the optional home fun problems, you should check your answers, okay? One last time. Kaylin,
2x on the outside.
2x?
Yeah.
We sure that's greatest common?
Squared.
Ah, 2x squared. What remains?
X plus 4x
4x?
squared.
Uh.
No x.
No x. Right? 2x squared times 4 makes 8x squared. Second terms, Anya.
1.
Oh, well done. Now, this is also why I recommend not put the 1 here as a placeholder, +1. Way too often I see people not writing their signs, and especially, all right, this is the trickiest case right here. This is just a +1, but I write this in, right, to make sure that, because when I pull it out in the last step, I have a placeholder there. And then, of course, what remains? Anya?
X plus 4.
X plus 4. I pull that all the way out. And the big thing is I see people, when they don't write it, they have something like this. And when you pull your X plus 4 out, they're like, oh, times 2x. But that is absolutely not correct. All right, keep that +1 there as a placeholder. All right, because it identifies what remains of my terms. All right. The other big dance move, all right? So we did the box, okay? Box is for multiplying together. We do the diamond to pull things apart. Okay, now, I know this just looks like an X, all right? We're gonna talk about why it's a diamond in just a minute, all right? We're gonna talk about why it's a diamond in a minute, all right? The big part here is that box, we put things together, diamond, we pull things apart. But notice what happens when we spin the diamond.
Comes a box.
That's a box. Okay, so notice how it comes together. It's a circle. All right.
No, it's not.
It's a
It's a box. Okay. Related. All right. In some geometric shape. All right. The diamond. Now we write this as an X, but why this is a diamond is because of the pieces that are involved in it. Up here, this is the multiply term. Down here, this is the sum term. The terms on both sides are the factors. What we are going to do, the diamond is useful for pulling apart 3-term quadratics. All right, side note, a quadratic has the general form ax squared plus bx plus c.
X squared. Wait.
Ax squared plus bx plus c. This is called a quadratic, all right, for a very awesome reason. Quad typically means what? 4. But do you see 4? This is a quadratic. Do you see anything with 4? No. All right. Quadratic actually got its name from the ancient Greece, all right, when they were identifying something that is basically too wide. Specifically, in order to make a box, how many points does it require? 4. That's why they required it a quadratic, essentially something two-dimensional. All right. So again, fun fact, when you're on Jeopardy, I want to thank you. Okay, so the quadratic works like this, all right? In the diamond, the top term is the A times C term. The bottom term results in the B term. The factors are what we find using the diamond. It always works to this nature, so you have to make sure your terms are lined up in the correct order. The A term is the term next to the x squared. The B term is the term next to the x to the first power. The C term is the x to the 0, aka the number value. Notice also when we put numbers in the diamond, It is the numbers. There's no X's or anything in there, okay? So this is purely a technique to help us pull apart algebraic expressions, all right? But in the diamond, it's actually numbers. There are multiple cases of the diamond, which is what I have written here. Positive, top is positive, bottom is positive, negative, negative, etc. All right, so there's only results in 4 combinations. But basically, when you identify this, you run through the combinations. If you struggle to run through the combinations, for example, I started with a tough one so we could see this. All right, what multiplies to negative 40, 240, and sums to 8? That's not one I could think of on the top of my head. But what I can identify, if that's negative and that's positive, what are the signs of the 2 values? Negative and a positive. Which one will be bigger? A big negative plus a smaller positive results in, when I add those together, a negative. Which means, let's do it again.
Positive.
The big one is positive, the small one is negative. All right, so I can identify that. But because that sign is negative, I know that one is negative, one is positive. If you have a hard time, all right, start with the values and always start with 1 times 240, right? That multiplies to 240, but the sum would be 241, and even if one is negative, right, 239. Then just do it one at a time. Go through your multiplications, right? In your calculator, you can do this really fast. Oh, 2 times 120, oh, 118, 3 times 80, all right? And I started with this big one so you could see all the possibilities. Also, this goes 1, 2, 3, 4, 5, 6, no 7, all right? 8, 10, 12, 15. This is literally all the possibilities, all right? Of any 2 numbers. List them out and figure out which one works. Looking at these possibilities, what are the 2 factors?
12 times negative 20?
Yeah, 12 and, yes, 12 and 20, all right? And then we'll identify the signs in just a minute. 12 and 20, because the difference of those, if this one is the big positive, that one is the smaller negative, that results in 8. Basically, you can run through the list. Now, good news for us, we usually don't do numbers that giant, but sometimes we do. And it's just your multiplication table. I mean, so, all right, we get our 12 and our negative 20. All right, we can then break it apart, all right, and identify what our factors are. All right, we're going to go through that step in just a minute. So our quadratic. The good news for us, this is the simplified version. If the A term in a quadratic is 1, I can jump straight from the diamond to my factors. All right, this is what's called simplified diamond. All of these ones we're going to look at are going to be the simplified diamond to start. So, factor completely. I have 3 terms here. All right, notice it is a quadratic. I have an x squared term, x, and then a number. Quadratic follows that exact form every time. Okay, so there's no x cubes or x to the fifths. All right, it is an x squared. All right, 2-dimensional term. So to do my diamond, AC goes in the top. 1 times 81 is 81. The B term goes in the bottom with the sign attached, all right? So always keep the signs with them. So then I just say, what multiplies to 81 and sums to negative 18? All right, so start with the signs. If that's positive and this is negative, what are the signs of the factors? Negative and a positive? Negative times a positive makes a negative. So, Anya?
They're both negative.
They're both negative. All right, both negative actually is kind of the same as both positive, which means what you get to do is just ignore the signs. Basically, what times what makes 81 and sums to 18? 9 and 9. And yes, negative 9 and negative 9. And oh, look, I identified my factors, which means then this becomes x minus 9 times x minus 9. And then just to refresh, I can also write this as x minus 9 squared. We talked about this quite a bit, right, prior to the midterm. Now, be aware that either of these are correct, and a lot of people like to leave it like this, but I just want to refresh everyone what that means. All right, let's jump down. 5x squared minus 15x minus 140. I can jump to the diamond immediately. 5 times 140 is
A lot.
big. So that feels kind of tough.
700.
700 and something? Okay, so better yet, think if I can make this easier. Do any of those have a greatest common factor I can maybe pull out? 5. Always start with greatest common factor. I want to make this clear. The diamond still works with big numbers. It works with the biggest numbers. But it's harder for me to think of values that I can go through with the multiplication, all right, on large numbers than it is with small numbers. All right, x squared minus 3x minus, I don't know, what's 5 divided into 140, 24?
28.
What is it?
28.
28. Ah, darn. All right, then I can do the diamond. Negative 28 and negative 3. Are we starting to see what are the factors here? MJ. What are the factors? What multiplies to negative 28 and sums to negative 3?
Sums to -3. It's gonna be a negative and a positive.
It is a negative and a positive. If you struggle, start with the numbers. 1 times 28, 2 times 14. That's actually all the options. 4 and 7, which one is which?
The 7 is negative.
That is correct. And again, if you get stumped, all right, if you get stumped, list out the numbers. With small values, there's not going to be that many. Literally, there's all 3 possibilities here. All right. Now there could be more, and we saw like that's why I started with the case with like 10. Okay, but even in that crazy hard case, 10 possibilities, still not that many. All right, and then lastly, once I have the diamond set up, I can jump to the factors.
And then you just bring your greatest common factor down.
Excellent point, yes. And then make sure you bring, yes, the greatest common factor, all right, that you had initially, all right, and maybe left behind, bring it back in. Because this needs to end up as this, right? This actually looks complicated. That actually is simple, all right? This is in really simplified terms. Look at my numbers, 5, 7, and 4. That's way easier. That's the whole idea. In order to put this back together to get this, what do I do first? Box, then rainbow. Be aware, super important note. The temptation is if you rainbow this, this only goes into one term. Rainbow is the last step. Always box first, then rainbow. All right, the temptation is this does not rainbow into this and to this. Okay, this only rainbows into one of the multiples, which is why we do the order. Box, then rainbow. All right, again. Do I want to diamond this?
Do you want to take it? Greatest common factor.
Greatest common factor, that's always the first step. Maddie, what are my factors for this diamond?
I was just trying to do it.
Let's start with the signs. One positive, one negative, both positive, both negative.
One, well, both words. Both negative.
Both negative, that is correct. Negative times a negative, all right, makes positive, negative plus a negative makes a negative. I know that seems crazy easy. The only trick of this, it's the arithmetic that you already know. So that basically means I can ignore all the signs. Basically, what multiplies to 24 and sums to positive 11?
Negative 8, -3.
Yeah, 3 and 8. Thank you, Maddie.
You're welcome. I always wanted my name to be Maddie.
No, it's not. Everyone has been named.
And then I can jump to the factors. The diamond makes all of this very, very easy. Now, be aware, one of the big things in Pearson MyLab and Mastering, it doesn't show the diamond. It says that basically you should be able to look at this and pull it apart. The diamond is just a helper step, all right, to walk through our logic of what we're doing. Okay, if you can look at this and pull this apart, that's fine too. Because all this is reverse box, reverse foil, right? I can look at this and I can pull this apart, all right? I say, oh, you know, what times what makes 28 and figure that out. Then it's got a sum to the middle term. So either approach. Square. All right. Maddie again. Maddie. What do we need to do first, Maddie?
Find the harmony, which is 3.
Greatest common factor. You are absolutely correct. Pull a 3 out. And these are my absolute favorite diamonds because the top number is the multiplied number. 5 is what kind of number that we just talked about?
Prime.
Prime, which means what are the only two factors? 5 and 1. And then I just need to determine the signs. One negative, one positive, both negative. What are we?
Negative, negative.
Both negative. All right, as soon as you see a prime number up top, I don't need to go through the whole list. It's always one in itself. Also, fun fact. Does anyone remember the name? What is a number that is not prime called? It has multiple ways, 2 times 7, you know.
The vowel? No, I'm just kidding.
No one remembers? Composite. Do we remember? Does that sound familiar? Again, fun fact, Jeopardy type question. All right, so then this becomes 3 times x minus 1 times x minus 5. All right, and one more, 5x squared minus 4. Greatest common factor? 5. And then this is kind of a tricky diamond. So we just said that the diamond is used when we have quadratics, 3 terms. But I only see 2 terms here.
See something. Be like x plus 3, x minus 3.
Oh, yes, you're a step ahead. What do we fill in the diamond?
I don't know. 0.
There is a 0 in there. This is just like we did with division. What term is missing?
0x.
0x, all right? The 0x, because x squared plus 0x minus 9. The term is there, all right? It's just a 0, which means that in the top piece, that is -9. In the bottom, which is the b term, which is 0 here. So you can write this out just like we did with division, all right? Just to give you 3 terms again. But that middle term is a 0. These say the same thing, right? You can put it in there as a placeholder, just so you know. And then, yes, all right, Anya, you're already ahead. What multiplies to -9 and sums to 0?
-3, +3.
-3 and +3. Notice how the diamond still works here. Okay, -3, all right, times +3 makes -9, -3 plus +3, all right, makes 0. So the diamond works in every single case of anything, all right, that is a quadratic. So in all these cases, notice, all right, how the factors immediately become the pieces, all right, of our polynomial. This worked because in all these cases, notice the coefficient, the number in front of the x squared term. What's the number in front of the x squared term on this one? After we did the greatest common factor, when we actually did the diamond. 1. What's the number in front of the x squared term here? 1. In all these cases, 1, 1, 1. All right, this, all right, and that was the initial instructions. Diamond method. If a equals 1, we can jump to the factors directly from the diamond. All right, that's what I was saying. This is the simplified diamond. Now we're gonna look at the complete AC diamond method. Also, we call this the full diamond. This concept, the diamond still works, but we have a few more steps in the middle when our terms are a little bit more complicated. This is when the diamond really shines because, all right, it's really hard to look at this and identify the factors, right? And one more warning, what my math lab does, it says, I should be able to look at this and identify what two pieces multiply to this. Here's the concept. So 3x squared, I can sort of figure this out. Good news. What are the only two things that multiply to 3x squared? What?
1 and 3.
1 and 3? And the x squared part?
3x.
X. So that means I have a 3x and an x. Okay, so I figured that out. What about 8? 4 and 2, is that the only possibilities? 1 and 8. All right, so there's 4 combos there. Now here's the question. Does the 1, 2, 4, or 8, does it go here or here?
Oh.
And which one? Does the 1 go here? Does the 8 go here? Does the 4 go here? Does the 2 go here? Or is it 2 and 4? Is it 8 and 1?
It would be 2. And 3 times 6.
Okay, exactly what you're doing. You're absolutely right. You're on the right track, but you're seeing what you have to do, right? The idea is because we have 4 possibilities, all right? You have to figure out, and yes, all right, so I see you're already getting there. Some people are really, really good at that, and you could slowly kind of pull it out. Okay, 1 piece at a time. I'll put the 2 in there and then the 4, and then 1 will be positive, 1's negative, or they're both negative, and I'll slowly figure that out that way. The idea is that's the method I hate. That's also what I call guess and check. All right, it's essentially guess and check, and it can take forever. If that first number was a 6 and the last one was an 8, now I have even more combinations. All of a sudden it becomes 6 times 3, all right? So you end up with 12 possible combinations with the signs that times 2. All right, so what am I, 24 possible combinations to start figuring that out. Depends how fast you are with guess and check. The diamond will break this down in a methodical process that we can go through and works every single time. But my point is I wanted to show you this. And so Anna, you might actually be good at that and you can jump straight to it, skip the diamond entirely. All right, whatever is fastest for you. Like I said, I hate that method, so we're gonna do the diamond. And somehow, whatever my guess and check approach is, I always start, it's the last option that I guess and check. Of all the combos, if there was 24 combos, it took me 24 tries. So, as always, greatest common factor, what can I pull out here? A 1. Yeah, there is nothing to pull out. So that means we have to do the diamond. All right, and this one's gonna be different. The top term is the A times C term. In that case, that is 3 times -8. So the top number is -24. The bottom term is still the B term, which is -10. Notice again, I'm just using the numbers. And so this part of the diamond still remains the same. Okay, so then I say what multiplies to -24 and sums to -10? 12 and 2, -12, -2,
-2.
12, -2.
-12.
Oh, okay, thank you. All right, I was having some trouble there. All right, -12, +2. Now, here's the different part. Rewrite the B term using the factors. Now notice, when I drop this down, 3x squared and -8. The A and the C term, I dropped down exactly. I didn't change anything there. Then I'm gonna write -12 and 2, the exact factors that I had from the diamond. But this is a polynomial, so I have to carry my variables with it. Now, this is easy when I have x's. We're gonna see on the last one, when you have lots of variables, you wanna be very clear here. This is -10x, which means I have to put the variable on both of those factors. Now, notice what we did. Are these the same? The same in terms of, does this equal this? Yes, all right, no, they're not the same because obviously there's different stuff right here. But notice, -12x plus 2x, does that make -10x? We are doing reverse combining like terms. Again, everything in factoring is pulling things apart. All right, so it gets a little messier before it's gonna get better. So all I did is pull apart that top term. Now, here's the really good news. I have 4 terms. What did we just learn about how do you factor 4 terms?
Separate the 2 and 2.
Grouping, all right? 2 by 2 grouping. So, of the first 2 terms, what's the greatest common factor?
3x.
3x. And what does that leave?
X minus 4.
X -4. Of the second 2 terms, Fred, what is the greatest common factor?
2.
2. When I pull out a 2, what remains? Still on Fred.
We got X and -4.
And -4. Brittany, does that make sense?
Yeah.
Why?
Does it get you back to the other equation, the original?
I don't think so. I mean, well, yes, but I don't think that's why it makes sense. How do I know that what Fred told me, this X -4 is correct?
So if you rainbow it,
If I rainbow it, it becomes this. Is there another way to check myself? MJ?
Because it's the same as the other parentheses.
Because it's the same as the first one we did. These have to match. If they do not match, either it was prime and it didn't work at all, or, all right, I messed up. Then pull that X -4 all the way out. And that leaves, what's the other factor?
Three X plus two.
Now, yes, Brittany, what you were saying, that this, when I box this back together, that will result in what we started with every time. And notice, were we kind of close, right? And Anna, you were actually saying, you were like, oh, I think that it's 3x plus 2, right? Which means the other term, oh, was x minus 4. Oh, you were actually really close, right? So we were starting to get it. This process, right, is methodical, takes you all the way through it in a step-by-step approach. But I was like, of course, there are other ways to do it, and that's all I wanted to show you guys. All right, let's do that a couple more times to practice that method. All right, 8x cubed plus 22x squared minus 6x. First things first, always.
Just 2x.
2x. I was like, what about a 4?
Yeah.
No, why not?
What is 6 or the 22?
It doesn't go into 6 or the 22, not as an integer, right? All right, so pull the 2x out, greatest common factor. This is the big one because the full diamond actually gets long. Don't forget we have this, all right? So we need to remember to bring this down at the end. That's the biggest thing, is that a lot of times we pulled that greatest common factor out, that was good for us, and then people forget it, all right? And don't put it back at the end. So remember, we need to come back for that. All right, now the diamond. All right, so we're getting better filling this in. Brittany, what goes in the top?
The top, we. 2 times the 4.
Nope, the 2 is the greatest common factor, so that's done for a minute. We're just looking what's inside the parentheses.
The 22 would go on the top.
Inside the parentheses here. It is A times C. Which term is the A? Which one is the C?
Oh. So the A would be the first term,
Which is,
4x to the squared.
A is just a number.
A is the negative.
Okay. A is just the number in front of the x squared. X squared.
Oh.
4. All right, so the 4. Where's the
Four.
C term?
Oh, 4 times the negative 3.
-3.
You're negative 12.
Correct. The bottom term is the B term,
Which is your 11.
11. There we go. All right. I don't remember who asked that. Josiah, what are the factors? What multiplies to -12 and sums to 11? I need 2 factors. If we get stumped, list them all out. That is literally all the possibilities for what multiplies to 12. And notice, I was like, we've done this a couple times. 3 possibilities is how many. I was like, ideally, just start going through what multiplies to 12. Like, that's it. And remember, we're only doing integers. There are a lot more things to multiply 12, but nothing with whole numbers. So what are the 2 possibilities? 3 and 4? Let's do the signs. If I have a positive in the denominator, sorry, not denominator, bottom of the diamond, all right, and -12 in the top, what are the signs?
You need 1.
1 negative, 1 positive. Okay, so if I put 3 and 4 in there, that does multiply to -12. -3 plus 4 becomes 1, definitely not 11. Okay, so I think I missed there. Anyone else? Someone help Josiah? It's 1 and 12, which is which?
The. Yep, what she said.
-1, +12, all right? Again, do the signs, list all the possibilities. I mean, that's the way that this diamond, right? And again, this is our first day with it. As you practice this thing it saves you tons of time, just speeds everything up, all right? And once you become really fast with this, all right, you start seeing it.
Now rewrite.
Now we rewrite the middle term. So 4x squared and -3 do not change. Then I have -1x plus 12x. Ooh, this does bring up something else. It does not matter the order in which you write these factors, so I can write this -1x and 12x or 12x and -1x. It will work either way, okay? And then factor by grouping. Of the first two terms, what should I pull out? Bryant? I'm gonna do factor by grouping. What should I pull out of the first two terms?
X.
X. What remains when I pull an X out?
4 and X, I'm pretty sure.
I'm sorry, say again?
I'm pretty sure it's 4 and X is 0. I might be wrong on that.
X times 4 makes,
X times 4 would be X to the 4.
4 times X becomes
4X.
4X. So is 4X the same as X, 4X squared?
No.
Ooh. What am I missing? What do I need to attach to that 4? X times what makes X squared?
X times X.
X. So I need another X in there. Okay.
Okay.
For the second term, X times what makes -1X?
-1.
-1. All right, so we gotta make sure we have all those pieces in there, right? Once again, the 1 is in there. A lot of times it's just a placeholder, right? Because even though I wrote that as -1X, that is just also written as -X. All right, of the second two terms, Kaylin, what should I pull out?
3. -3, sorry.
-3? It's still a +3. The signs are okay. If you pull an, I'm glad you brought this up. Let's actually do this. -3, if I pull a -3 out of this. All right. What's the first two terms? Or sorry, first term of the second two terms?
4x.
It'll be 4x. All right, what about the second term?
Would it make it 0 if it was a negative?
No,
Oh, 1.
be a 1. Now, here's the issue, and this is really common that people are like doing this, okay? Couple things. Notice, we made a mistake. Here's the other thing. The temptation is to just put 4x here. But -3, remember when you rainbow, this whole piece comes in. -3 times 4x becomes -12x, so that sign didn't match. -3 times 1 becomes -3, so the second term is correct. And we have to do this kind of, all right, sometimes like you have to adjust the signs, pull a negative out, and that flips both signs. But this would actually be -4x plus 1, all right? And I say, oh, this is almost this, but now if I pull another negative, making that positive, that'll flip both inside signs. And I get what I actually am looking for. So the temptation, all right, 1 is positive, 1 is negative. I can usually still pull a positive. Sometimes I might have to pull a negative, but it flips both signs on the inside. All right, and then pull it all the way out, 4x minus 1 and x plus 3. And is that our answer? No, don't forget, we had it up here highlighted in red. Bring that greatest common factor all the way down. That is then our answer. So again, a lot of details, right? I mean, we got factor by grouping in there, we got diamond, we got greatest common factor. Okay, lots of steps of the polynomial dance. All right, I can box and rainbow it back together at the end. All right. But nice methodical approach. All right, the more we practice this, the better we'll get. Let's do one more of these. And here, oh, here's a really good one. 24. Once again, first step, most important step.
You only take out two.
Yeah, with all that, it's the only thing I can pull out of two? Yes, it is. All right, which means, oh, we have some excitement ahead of us. That does bring up a big note. If you're not sure, always start with something easy like 2, and then look at it again and see if I can pull anything else out. Because you can always pull out more stuff, and I can end up with 2 times 2 times 7 times whatever out here, and then just multiply it together to create the greatest common factor. So I can start with any factor. But then I double check, okay, 12, 17, and 6, do they have anything else in common? No, why not? Because there's an awesome number in here. 17, it's what kind of number? Prime. All right, so that one's prime. A squared, AB, and B squared. Do they have any terms in common? No, right? Because this is A times A times B, B times B. All right, so this one doesn't have any B's, this one doesn't have any A's. Now, regardless of how many additional variables, the diamond still works because the diamond deals with the numbers most of the time.
Most.
Well, okay, all the time in the diamond, and then at the end, we put the variables back in. Okay, so what goes in the top?
12 times 6.
12 times 6.
72.
What goes in the bottom? And then what multiplies to 72 and sums to, let's do the signs first. Positive in the numerator, in the top, negative in the bottom. Oh, Ann already got it. Look at you. -8, -9, 2 negatives multiply to a positive, 2 negatives sum to a negative. Okay, here's the big thing. All right, when we rewrite, remember that the first term and last term, they drop down. Nothing changes. 12a squared, 6b squared. You don't touch those. They literally come all the way down. Then rewrite the middle term using the factors. So -8, -9, exactly what I pulled out, all right, of my diamond. Go ahead.
You probably are gonna go into it, but where would you put the A, B, and B squared?
That's exactly. Then attach the variable, all right? The variable in the -17 is what? AB. I have to attach that to my factors. Because again, all we're doing is breaking apart that middle term. The whole point of the diamond is to turn this into 2 pieces. -8 plus -9, what does that become? Right? It has to be this number, right? So it's always just a quick check, right? As you're going, check yourself to make sure that that made sense. If I had 72 and 48, that definitely doesn't become -17.
Why wouldn't we do -8A and -9B instead of the AB for both?
Because
these combining like terms, negative 8ab minus 9ab becomes negative 17ab. No such thing as, what were you saying, AA and BB?
Negative AA and negative 9B, like each had the
Oh,
different.
each has one variable, because an A and a B don't combine to become AB.
Okay.
Only multiplying, but they don't sum together, right? Your A times B becomes, but this is summing,
Okay.
right? This variable, all right, has to be exactly this variable. And again, remember, it's always back. A is a 2, B is a 3. All right? 2 plus 3 makes 5. 2 times 3 makes 6. Depends if you're multiplying or adding. All right, and then factor by grouping. Oh, this is a really good one.
Why doesn't the symbols match up?
Or the negative six?
Okay, hold on, one question at a time.
Sorry.
All right, Anna,
Does it matter which side you put the -8 or the 6 on? Or like when you're factoring the two pieces, if you switch those, would it have it like?
switch what, 2 pieces?
The 6b squared and the -8ab. Like if you put the 6 with the 12 and the 8 with the 9, would it do anything different?
That definitely would do something different,
Okay.
okay? The 8 and the 9 can be flipped. But this is the A term, this is the C term,
Okay.
right?
Oh, so the factors can, okay.
But the factors, the 9 could be here and the 8 could be here, and we can do it the other way.
Okay, it doesn't matter which side.
Yeah, because I could have written I just coincidentally wrote the 8 first, I could have wrote the 9 first,
Okay.
right? That makes no difference. This, all right, needs to be here, this one needs to be here.
Okay, yeah, the factors can go. both.
Maddie?
How does the symbols won't match up when you do the next step? Because you have an A squared and a B squared.
That's a good question there. I have a feeling they're gonna match up.
Okay.
Let's continue. I was like, it may not look like they're gonna match
Yeah,
up,
it doesn't-
but they're gonna match up. It always works. Let's continue. So let's, one piece at a time. All right? What is the greatest common factor of the first 2 terms? Where were we? Anya, 3A. 3?
Okay.
4A.
4A. Were you looking at the second one already?
Nope.
4A. What is then left inside?
It'd be 3A minus 2B.
That is correct.
So you can pull out the A from the AB.
Because now we're back to multiplying. This is what Kaylin was saying, right? She was asking about summing versus multiplying. So notice, this is all arithmetic at this level, right? Yes, we have variables in there, but all we really do is, are we multiplying? Are we dividing? Are we adding? Or are we subtracting? It's really the 4 operations of arithmetic. But you add a few variables in there and everyone forgets their arithmetic and it becomes so much more complicated, right? But you always think back to the most base level of everything, Brian.
What do we do with the square?
What happened to it? I factored it out. A times A, what does that become? Just A times A. A squared. A times B. AB. Alright? Variable multiplication is actually way simpler than we think, right? Okay, of the second 2 terms, all right, this one's a tricky one. What should I pull out? Greatest common factor?
3B.
3B. What is the first term?
3.
3A?
Negative 3A.
Negative 3A. Because 3B times negative 3A makes negative 9AB. What is the second term?
2B. But then they don't match.
Kaylin, this is exactly what you were asking.
Yeah.
It was you, right?
Yeah.
Okay, yeah. Now they actually didn't work because notice back here, notice the signs, positive, negative, negative, positive. Notice how the signs are opposite on this one versus the one you were asking about, Kaylin? All right, since that's positive, negative, negative, positive, so what do I need to flip this to?
Negative.
Negative, that then will become?
Okay, so I was right the first time.
This is exactly what you were just asking, yes.
So then it would just be positive 3A minus 2. And it matches.
And that's the common way, what, the one you were looking at before though, notice it didn't work on this one because positive, negative, positive, negative. So we want that to be positive.
Is there a way to like avoid it from the start?
And then
Oh, no. I was like, you just have to pay attention, positive, negative, and if that is negative, then you say, I immediately want to pull out a negative right here because I see that first term or third term. I see that first term of the second part is negative, so I would pull a negative out. Now we match 3A minus 2B. Comes all the way out. 4A minus 3B.
All times
Wait a
two.
minute.
Oh, hold on. Fred, wait a minute.
Oh, no, I didn't get the. I missed, when I went up to give a section paper. This road.
And then someone else, a couple of you guys were commenting. What else am I missing?
And then the 2.
Bring down the 2. On this one, because this one just looks like crazy complicated, I'm not sure what I'm looking at. I was like, how does that end up back at this? So let's verify this one. Let's check this, the box.
Scattered.
So 4A times 3A becomes 12A squared, negative 8AB, negative 9AB, positive 6B squared. When you come out of the box, remember, we love our diagonals. 12A squared minus 17AB plus 6B squared. Rainbow. Is that what we started with? It sure is. All right, again, I keep wanting to say circle. Notice the circle of algebra or the box of algebra, all right? It all relates back. Again, all right, what we did before, all right, and every time you can check it to make sure what you had, all right, because way too often, this answer that, right, we have, we went through that steps, but if those numbers didn't make sense and you skipped it and someone just wrote something random, you want to make sure that, can I check to see, is that even close? All right, box and the rainbow is all it takes. Very quick check. And we're actually faster at multiplying stuff together than we are breaking things apart. Notice the steps involved in the diamond and factor by grouping, greatest common factor. Breaking things apart actually is more steps than putting them back together, because we're breaking them apart carefully. All right. Special factors, I bring this up because Pearson My11 Mastering, again, goes way into detail on like recognizing special factors. There are 2 types, perfect square trinomial and difference of squares. The names are completely irrelevant, but just be aware that when it says it views an example and it's like talks about this, okay? It's like, oh, you should recognize something as a perfect square trinomial when it has this very particular form, okay? You don't ever have to recognize a form because I see factor completely x squared plus 6x plus 9. How do I break that apart?
X plus 3.
Yes, what technique would I use to break that apart?
When we just did.
The diamond. I don't need to recognize anything because I say, oh, I see 3 terms, do the diamond. 9 and 6. 3 and 3. That literally becomes x plus 3 times x plus 3, AKA x plus 3 squared. So
And again, it's really just the warning that it's like, oh, obviously you should recognize a perfect square trinomial. But like, if you do, great, and Anya, you did, that's fantastic. But also, who cares? Because the diamond always works, right? If you have a method, you don't need to learn, oh, this is a special case, and this is a special case, and this is a special case, because there's gonna be a lot of them, but we have a master technique that does it every single time. To that end, difference of squares, I have lots of these just because this is very, very common, mostly because we already did one of these. This is two terms, but actually uses the diamond because all of these have what in common? 0x, yes, the placeholder in there. All the diamonds of these have 0 in the denominator. So I can see that just by looking at it. So the diamond works on all of these, all right? For the first one, -64 and 0.
-16 and -16.
No, not 16.
16, that's left.
You're close.
Yeah, 26.
All of them.
Wait, what's a different one on the top?
What times what multiplies to 64 and sums to 0? That means it's the same number, 8 and 8. I was like, we're all overthinking that one. 8 and 8, right? X minus 8, X plus 8. For the second one here, I actually already did the first and important step, which is what?
All right, I mean, greatest common factor.
Greatest common factor, pull a 2 out. And then we end up with -4 and 0 for the diamond. 2. Ah, we got that one right. Need 2 factors though. Negative, just want to make sure. -2 and +2. And lastly, -144 and 0.
-12, +12.
-12, +12. Now, I could run through that one in more detail. But this is, when you see a difference of squares, one of the nice things, notice the pattern in those other ones. What is the pattern? What do you see in the pattern? With the values specifically, they're the same, but one's negative, one's positive. So once you see that pattern, you can jump straight to the factors, right? That's not gonna be -12, +12, because this one we're gonna have to do the full diamond on. I'm gonna have to do the full diamond on that one because why?
Is A and a B?
Nope, nothing to do with the variables. What's the term here? What's the term here? That's a 1. That's a 1. This is a 16, which means I have to do the full diamond. This isn't just X plus 12, X minus 12, or A and B. But what I can see, what times what makes 16? That's the same.
4 times 4?
4. So 4A. What times what makes 9? That's the same.
3.
Four A minus 3B, 4A plus 3B. I can identify that just by looking at it, if you're able to identify that as a difference of squares. But otherwise, I could still do the full diamond on that. Run it down, break the middle term, which was 0 AB into -12 AB, +12 AB, and then keep going, all right? If you're able to recognize difference of squares, that speeds you up a little bit, but you don't have to. Every time, you can still do the diamond. Okay. The other way, we did 2x2 factor by grouping. The other way is 3x1. This is the hardest way. All right, this is the toughest thing that we're gonna do this whole chapter. You should always start, I see 4 terms, start with 2x2 factor by grouping. That's the most common. Of the first 2 terms, what would I pull out? X. Of the second 2 terms, what would I pull out? A 1. How'd we do?
Well, they don't match up.
It did not work. This is the way that you get to 3x1 grouping every time. You always start with, I see 4 terms, I do 2x2 grouping. I notice, all right, the terms are not the same. Then I try and factor it differently. There is one, it could be prime, which means I can't factor it at all, but always test everything before you just throw your hands up and say it must be prime, right? So 3x1 is exactly what it sounds like. With 3 terms and 1 term. So we just have a different set of underlined values. Of those first 3 terms, notice what we have. So ignoring the negative y squared. X squared plus 6x plus 9, what is that? That's a quadratic. And what technique do we use to factor quadratics? The diamond. 9 and a 6. 3. X plus 3 times x plus 3. AKA x plus 3 squared. The second term is just 1 term, which means I need to write this as something squared minus something squared. What times what makes y squared? Y. Just itself. Now, this is why this is the most tricky. So that actually feels like that all made sense. This is now a difference of squares, but with weird terms. I wrote it as piece squared times piece squared, so we could identify the pieces. We just said that a difference of squares is something with a positive and something with a negative. The first term is something squared. The second term is something squared. The red piece just happens to be 2 terms, so it's not as simple, all right, as we were doing above. But the first term is x plus 3. The second term is just y. This is a 3-term difference of squares when this factors all the way down. But it's still a basic difference of squares. Something that is the same times something that is the same, but the sign is flipped. One is positive, one is negative.
Do you,
Go ahead.
when we have this on a test, do you want it written, the first one, or like? I mean,
The only thing that matters is the last step. Whoops.
okay,
That's, yeah.
I do not care.
you don't. You want it written like that, not like that.
Oh, this is not factored. That right there? Yes, thanks for pointing that out. That's not factored. That's just the same thing written in a different way. Factored is when I have something that I can basically box or rainbow together.
Okay,
Can I box or rainbow this?
figure out how, no, okay.
All right, so you want something that you can completely box a rainbow. That's what factoring completely is. Excellent point. Glad you brought that up. Knowing
In my
when
mind, I would have stopped at that.
you
one.
would have been like, oh, that looks,
Yeah.
that is broken down, not far enough. All right, our goal is to break things down into completely factored forms. I'm glad you brought that up.
Yeah, I would have stopped.
Knowing when to stop and when to keep going is a key thing, all right? That's what we're doing in algebra. All right, almost done. One last wonderful step, and I love this because this is my favorite move in the entire polynomial dance. Okay? This is such a good move, and we're gonna show why here. Make sure we have enough time because it's super important to get 15 good minutes, all right, to talk about the dance. 10, 12 minutes, to talk about the dance move, well, 2 minutes to solve the problem. All right, so, all right, this sum or difference of cubics, all right, they have pretty like complicated looking formulas. When we break these down, we kind of do similarly to what we had before. All right, in that factoring three-term difference of squares. I identify, all right, I already filled that in because I was too ahead of myself. I need something cubed plus something cubed. So what cubed makes W cubed? Keep just giving it away.
No wonder.
What cubed makes 8z cubed?
2Z.
2z, right? So you're breaking down both the number piece and the variable. Now, the formulas are here, but in order to actually identify this, this always becomes, it's something times something because we are doing factoring. Once I identify those pieces, I have my W and my 2z. In order to find the pieces of the next three parts, the first term is the first term times itself. W times W, what does that become? W squared. Then it becomes the combo, W times 2z. What is that?
W2 and 2Z.
2WZ. And then the last term times itself. 2z times 2z, 4z squared. What does that look like, kind of? A bunny, okay? So that's a bunny. I was like, the 2 ears didn't quite match up.
That's funny.
All right, in order to identify then the signs that go in there, we use the acronym SOAP. Same, opposite, always positive. Okay, so notice what we started with, that was positive, so same sign. Positive. Opposite sign. Last sign, always positive. And we have factored a cubic down, all right, using the bunny face and SOAP. So hence we use SOAP on the bunny. This is what we call wash the bunny. So you wash the bunny. This one everyone's got to stand and do because this is just such a good move. This is my, this is, okay. I was like, come on, give everyone, we're almost done. And everyone needs to stretch anyway. So go ahead, stand, stretch. All right.
I'll stand, but I can't.
Okay, you can't hop. All right, well, you can definitely do the bunny ears. All right, so ready? Wash the bunny. All right.
Can't do that many things at once.
Well, you're not doing the pat and rub, whatever it is, pat your head, rub your stomach. No. That's just one stationary. All right, so wash the bunny, that's how you factor a cubic.
Will you go over the SOAP part again? What was that?
So the SOAP is how you identified the signs.
Oh,
Yeah.
oh, okay. I already
So
get it.
I just filled those in with blanks, all right? And then I did the signs. That is positive because that's literally what the problem said, but it can work with the negative too, all right? So same is your first sign. Opposite of positive is a negative, and then the last sign, always positive.
Okay.
So there's 3 signs in there, same, opposite, always positive. So the AP is the last sign.
I was with you to the 4Z, man, I was like. where you-
So W times W is W squared.
Yep.
W times 2Z, 2WZ,
Yep, got you there.
2Z times 2Z, 2 times 2, 4, Z times Z, Z squared.
Z squared.
2Z times itself, 2Z times 2Z is 4Z
I
squared.
lost you, yeah, where you time it by itself.
That's what the ear is. So the first one, W times W,
Time it by-
this is the same thing. Just 2, this one just has 2Z instead of just Z.
Gotcha.
So it's just 2Z times 2Z, 4Z squared.
So the 2 ears is the first and the last term, which is just, it's timesing by itself. All right, so wash the bunny face, absolutely fantastic, best dance move. Notice we did greatest common factor, all right? Do the diamond, all right? We didn't really talk about it because grouping is really just like, do the group, all right? And then wash the bunny face, all right? So that was a big lecture with 4 awesome dance moves, but definitely the best dance move, wash the bunny face. Hard to really get better than that one. That is the pinnacle of the polynomial dance. All right.
That scribbles make sense to you? Yeah, I put teeth on it, so I know it wasn't.